Okay, we're going to talk about prisms and surface area and volume. So first off, a prism is a solid figure with two opposing faces that are congruent and parallel. Congruent means the same size and the same shape. Parallel and sides that are parallelograms. So X is explained in Legos. Here I have a face with the same face opposing it, and they are the same shape and same size, so they're congruent. They are parallel in parallel planes, and so this is a prism. And all of the other faces connecting these two congruent and parallel faces are, in this case, rectangles. They could be offset. If you imagine keeping them parallel, sliding the top one to the right, the bottom one to the left, imagine what would happen to this face right here that's facing you. It would stretch, you'd get the angles to change, and you would have this turn into a parallelogram. Often we think of prisms as right prisms, where all these sides are rectangles. But technically it's still a prism, as long as these two opposing faces that are the same shape, that are congruent, are parallel. So there's a prism. Here's another prism. Okay, this would be a rectangular prism. We name a prism generally by those two faces, what shape it is. So this is, if this is a trapezoid, two parallel sides here and then two non-parallel sides, we would call this a trapezoidal prism. Here everything's a square or rectangle, so we'd call that a rectangular prism. I had a web page up here we could look at, just some others. So a triangular prism, you'd have two opposing congruent triangles. Maybe a pentagonal prism. Basically for us in our class, think about an inventor creating a profile, a sketch, a 2D sketch, and then doing an extrusion. So it becomes a prism when we do that even extrusion all the way back. And we name this prism based on the profile that we had created, the profile that we extruded. Okay? So a cylinder, if those two opposing faces that are congruent are not polygons, but they are circles, we don't call this a prism. Okay, a prism by definition has to have polygons as all the faces, and all the faces have to be flat. Where here in a cylinder, this side right here that's connecting the two circles is not flat, so it's not a face, at least not a flat face, and these two sides here are not polygons. So, but we are going to talk about cylinders as well. So this is a cylinder. You have two congruent circles connected by what ends up being one rolled up, one curved rectangle. Okay, so there's a little bit about what is a prism and a cylinder. Okay, next, what is area? We're going to be measuring the surface area of these solids. Area is the measure of how many squares it takes to cover a surface, and those squares are 1 unit by 1 unit length and width. So just a quick little sketch of, basically illustrating that we're trying to count how many squares it takes to cover a surface. These units, because we're not measuring a length but measuring squares, we write our units squared. So as an example, when you see this, that exponent of 2 means that it's square centimeters. Okay, that what we're measuring and recording is how many squares that were 1 centimeter by 1 centimeter in length it took to cover a surface. Okay? All right, so if we're going to calculate area, we need to be familiar with some area formulas. So here are some common area formulas for you. A rectangle is length times width. A triangle can't be just length and width, or often in a triangle we refer to a side as the base. Okay, because if you did base and height, that would actually be just like length and width, and you'd get a rectangle again. And we
At this time, we need members of the senior best group. The senior best group, please report to the gym.
And we can see that if you did this length times this width, that you would include all this space that's really not part of your triangle. And so that's where the 1/2 comes into play. It's 1/2 the base times the height. Just a friendly note, in a triangle, one side is usually picked as the base. The height is the distance to the opposite vertex from that base, okay, or from the vertex down to the base, but that height has to be measured perpendicular along a path that makes a right angle with the base. Okay, we don't measure just along any path to the base. We want the perpendicular path because it's the shortest path, the shortest distance to go from this vertex to the opposite side. If you happen to have a right triangle where two sides are already forming a right angle, then you can just use those two sides as your base and your height. But then again, a triangle is 1/2 times the base times the height. Okay, a trapezoid is a quadrilateral, a four-sided figure where two sides are parallel and two sides are not. The two parallel sides are called the bases. They're always going to be different in length. Okay, if they were the same length, that would make these two sides be parallel, and you'd have a parallelogram. So these will always be different lengths, and to find the area of a trapezoid, we average these two, so that means to add them up and divide by 2. It's usually written this way. Find the sum of those, they're in parentheses, find the sum of your two bases, and half it. Same as dividing by 2. So this really, you can think of this as averaging the bases, and then times the height. The height is the distance in between the bases. Again, that has to be on a perpendicular path to those two because that's the shortest distance. So we want the shortest distance between the two bases. And a circle. The formula to calculate the area of a circle is pi, which is a constant. Pi is approximately 3.14. But it's an irrational value, which means it's a never-ending decimal and it's not repeating. So often we use 3.14 to approximate pi. And r is the radius of your circle, which is from the center to any point on the circle, that radius squared. So r times r. And really, if you think of why might we be doing that, imagine one r that's horizontal and one r that's vertical, so that you're starting to calculate an area. If you think of like a base and a height. Okay, so there's your r and r, 2 radii. Okay, so there are some area formulas for you. All right. Okay, next up, we'll do some examples after this. We're also going to be measuring volume. What is volume? Well, volume is the measure of how many cubes now, which is three-dimensional, a 1 by 1 by 1 unit cube, it takes to fill the inside of a surface. So just drew a quick sketch of a cube. Think of like sugar cubes. How many does it take to fill the inside? To calculate the volume of a prism or a cylinder, okay, prisms and cylinders, this wouldn't be true for pyramids or spheres or cones, but for prisms and cylinders where we have two congruent and parallel faces, okay, that are opposing each other, so the two opposite sides that are congruent, okay, and parallel, this will be true. You simply find the area of the base, and in these shapes, the base is referred to as the shape where there's two of them opposing. Okay, so these two sides are both called the base. All right, in a cylinder, the circles are the base. Okay, even if it's resting on its side, we still refer to those as the base. Okay, and then times the height, and the height will be the distance between those bases, even if it's resting this way, so it's not sitting on the base, the distance between the two bases is the height. Okay, we obviously might prefer to have it sit on the base so that the height is actually going up and down. Okay, so volume, just another little illustration. Think of this block I've got, a rectangular prism. So surface area, we've got, on this one surface, we have 9 squares. So we could say the area of this side is 9 square units. By having found the area of what might be the base, the side it sits on, okay, for every 1 unit in height, okay, that really then is telling you if there's that many squares on the surface, we'll go up 1 unit and you've really now turned that into cubes. How many cubes does it take to fill that? So multiplying by height is in essence trying to extrude this up and turn an area into a volume. Okay, and I forgot to write this on here, but just like with area, the units are written as units to the third power because we're talking about cubed units. So the third power is really the 3 dimensions. You've got your width, your depth, and your height. So as an example, if you had centimeters to the third power, we would say cubed or cubic centimeters. really would be cubic for there. So we'd say we have got so many cubic centimeters, just to make sure that we know we're not, even though we see a centimeter, which we think of as a length, this is not a length. This is talking about cubes, how many cubes it took to fill the inside of the space. So we're multiplying by the height, the area of the base times height, because for every additional height, okay, unit up, we've got another row of cubes that fits into the solid. Right, so the area of the base tells us how many cubes would fill up one row, one level, and times h tells us how many rows we have. So, you know, this is 9, we'd have 9 times 1, 9 times 2, 9 times 3 if we had a third row, etc. So in this case, we just had 2, so the 9 times 2 is 18. There are 18 cubes in this block. Okay? All right, some examples. All right, we're going to calculate the area of the base, and then the total surface area, and the volume for each of these. Okay, so with a rectangular prism, I would just say the side that it's setting on is the base. So capital B is going to be the base of the prism, and it's a rectangle, and so it's just length times width, 8 times 10, which is 80. Now, there are two of those, right? So if we're trying to calculate the total area, total surface area, I'll just put TA for total surface area. You guys know that that's going to be in a rectangular prism, hopefully, that there's going to be 6 sides. So it's 3, 4, 5, 6. And when we find one side, we've already found the opposite. So 80 and 80, top and bottom. Now, we can go through and go around and find the area of each of these sides. We can see that the height is 3. So this front face we can see as 8 times 3, which would be 24. But then if the front's 24, the back is 24 as well. The right side is 3 times 10, which is 30. So if the right is 30, the left is 30. You can do that. Okay, and then we just add them all up. So if we add these up, we're going to have 160 plus this is 48, so that's 208, and then 208 plus right here is another 60, so that's going to be 268. And I put a little note up here that we're going to assume all units were in centimeters. So what we measured, remember, were how many squares it takes to cover the surface. So those are not lengths, but how many squares. Okay, lastly, the volume. Volume's pretty easy. Because we already found that the area of the base, okay, if you imagine the base there being that rectangle, that's 8 by 10, okay, is 80 square units on the bottom. We just multiply that by the height of 3. And you really are multiplying then centimeters squared times centimeters, which will help you understand where we get the centimeters cubed. So 8 times 3 is 24, so this is 240 cubic centimeters. Okay? All right. How about a triangular prism? All right. Even though it appears that this is resting on if I drop in some extra hidden lines, maybe that'll help. You see it? But even though this is resting on a rectangle, this is a triangular prism. I have two congruent triangles that are opposing and parallel. So we refer to this prism by those congruent opposing faces, the triangles. So triangular prism. Let's start with finding the area of the base, the triangle. So in this case, that's 1/2 times the base times the height. For the triangle, the base and the height have to be perpendicular. I have two sides that are perpendicular, so that's the 3 and the 4. So it's 1/2 times 3 times 4. 3 times 4 is 12, and half of that is 6. So the area of the base is 6, and again, we're assuming centimeters on everything, so 6 square centimeters. All right, the total surface area. Well, you can have two of those bases, 6 plus 6. But now, in a triangular prism, because the base only had 3 sides, there's only 3 rectangles. So we've got each length of the triangle gives us one of the dimensions of the rectangles. The other dimension of the rectangles is this height. How far you go from triangle to triangle is really the height of the prism. So they're all going to be 6 times something. So this big one right here is 5 times 6, which is 30. Okay, I can make a little note that was 5 by 6. The one that it's resting on is 3 by 6, which is 18. And then the one that's kind of hidden around on the left side there is 4 by 6. So that's 24. And then you would just add up all of these values, right? So we've got 12, 6 and 6 is 12, plus 30 is 42. Okay, 42 plus 18 is going to get us to 60, and 60 plus 24 is going to get us to 84. Again, assuming that these are centimeters, that's just the total surface area from all 5 sides, so we're still talking about how many square centimeters. Okay, volume. Remember that volume is the area of the base, which is the triangle. So that was our 6, and that's really 6 square centimeters. That's an area. And we're going to multiply that by the height. The height is how far from one triangle to the opposing congruent triangle, and that was a distance of 6 units apart. That is a length. And so we have 6 times 6, which is 36, and the centimeters squared times another centimeters gets us to the centimeters cubed. So volume is 36 cubic centimeters. Okay, and just a couple others for you if you need. Here's a trapezoid. So finding the area of a trapezoid is 1/2 times the sum of the bases, 10 and 20. So basically we're averaging the bases of the trapezoid. So that's really 30, and half of 30 is 15. And then times the height of the trapezoid. Right now I'm just looking at the face of the trapezoid, is the 12. Okay, so we have, I'm really right here, averaging the bases, if you will. So 30, half of that is 15. And then I want 15 times 12. Let's see, that's going to be, well, 15 times 10 would be 150, and then another 30, so it'd be 180. Okay, 180, and again, assuming centimeters, so that is how many squares it takes to cover just the trapezoid. So if we want the total area, we need to go through and add up all the sides. Well, you're going to have 2 trapezoids that are 180, the front and the back, the 2 bases. A trapezoid has 4 sides, so there's going to be 4 rectangles. In this case, it's an isosceles trapezoid, so the right and the left side are both the same. Okay. But then the top and the bottom are different. Okay, so the bottom is 20, and then by your 50. So 20 times 50 is where I'm going to get those 2 numbers. So that's really going to be 1,000. And on the top, you've got 10 by 50, which is going to be 500. Okay, and then the right and the left side are going to be the same, so we just need to do 13 times 50. And let's see, that is going to be, am I right? Is that 650? Just thinking right? 13 times 50. We'll double check with the calculator. Yep, 650, just make sure I'm good. So in there you have 2 of those, 650 and 650. Okay, so we'll add all of these up. Let's see, 650 plus 650, that's going to be 1,300, plus 500 is 1,800, plus 1,000 is 2,800. Okay, so we're at 2,800, 2,800, and then plus this 180 and 180. So 2,800 plus 180 is going to get us almost to 3,000. We'll just be 20 shy, right? So 2,980, and then add in the last 180. So we're going to be at 3,160 centimeters squared. That's a lot of squares. Volume is, again, the area of the base times the height. The base was the trapezoid, and we found that to be the 180. The height is how far it is from trapezoid to trapezoid, which is the 50. So I really just need to multiply 180 times 50. And let's see, 180 times 50 is going to be 9,000. Just double check that. 9,000 cubes. Okay. Lastly, if you want to see a cylinder. So a cylinder, the area of the base is a circle. And a circle is pi r squared. The radius on this is 5. So we've got pi times 5 squared. 5 squared is 25. Sometimes people just leave problems like this in terms of pi. They never multiply the pi in, they just leave the pi as a factor. So they kind of leave it in a factored form and write it as 25 pi. If we wanted it as a decimal, then you could go ahead and use a calculator and type in, what is 25 times 3.14, and I get 78.5 approximately. So we could do that. We'd need to know that at this point, if I'm multiplying by 3.14, that's an approximation. Okay, so that would again be how many squares it takes to cover the surface of that circle. So if I want the total surface area, I'm going to have 78.5 plus 78.5. Okay, and then here's the one last one that we've got to figure out. Okay, let me grab a little scrap piece of paper here. A cylinder is really a rolled up rectangle, right? Okay, so we got the area of the two circles, but the other side, that rolled up rectangle, we've got to figure out, how do you find the area of that? Well, a rectangle is length times width. Usually what we write in geometry, right? So length times width, if we multiply those two. Well, putting it in the context of the cylinder, this length wrapping around the cylinder is the circumference, and then this width of the rectangle is actually the height. So to get if you kind of think of the net, if you were to unfold this, you would have a rectangle and you would have two circles. So what we're trying to add up. So we've got the circles, but we need the rectangle. The rectangle is going to be circumference and height. Okay, so circumference, maybe you don't know, circumference is pi times the diameter. So pi again is 3.14. The diameter is twice the radius, so that's 10. So 10 times 3.14 would be 31.4 approximately, right? We've approximated pi. So there's circumference, but we want the area here. So the area of that is the 31.4 times the height, and that's the height of the trapezoid, so times 20. So what's 31.4 times 20? 628. So that is going to be the rectangle. Okay, so to get the rectangle, it's really the circumference of the circle and then the height, the distance between the two circles. Okay, so we're going to add all these up. 628 plus the 78.5 plus the other 78.5, and we get 785. So the total area is 785 squares to cover the surface. Again, centimeters to the second power means square centimeters. And lastly, volume. Volume is super easy. Area of the base times the height. Well, the base was the circle. We found it. The base was our 78.5. The height is the distance between those, which is the 20. So we just need our 78.5 times our 20, and we get 1,570 cubes. It would take 1,570 cubes that are 1 by 1 by 1 centimeter in size to fill that cylinder. There you go. There's some examples. I hope that helps, and you are going to have some practice problems.